Few things in nature are as magical as a rainbow. After a storm, when the air is still wet and the sun breaks through the clouds, bands of red, orange, yellow, green, blue, indigo, and violet stretch across the sky. But how does this beautiful arc of colors appear? Let's uncover the fascinating science behind how rainbows form. To understand rainbows, we first need to understand light. Sunlight may look white to our eyes, but it's actually made up of many colors combined together. Each color has a different wavelength. Red has the longest, and violet has the shortest. When light passes through something that bends it, like water or glass, the colors can separate. This bending and splitting of light is the key to a rainbow. Now imagine the moment after a rainstorm. The air is full of countless water droplets, each acting like a tiny transparent prism. When sunlight hits these droplets, part of the light enters the droplet and slows down because water is denser than air. As it slows, it bends. This process is called refraction. Inside the droplet, the light bounces off the inner surface and exits again, bending once more as it leaves. During this process, the light splits into its individual colors, creating the rainbow effect. Each droplet sends light in a specific direction. Only the droplets that are positioned at the right angle, about 42 degrees from the direction opposite the sun, send their light toward your eyes. That's why you see a rainbow as a circular arc. If you could rise high enough in an airplane with rain below you, you might actually see a full circle of colors. The colors always appear in the same order, red on the outer edge and violet on the inner edge. This happens because red light bends the least, while violet bends the most. Sometimes, when the sunlight is especially strong, and the raindrops are large, you might see a second, fainter rainbow above the main one. That's called a double rainbow. The second arc forms because light bounces twice inside the droplets before it exits, and that's why the color order is reversed. You might wonder why rainbows don't appear every time it rains. The key is in the position of the sun and you, the observer. The sun must be low in the sky, usually early morning or late afternoon, and the rain must be falling in the opposite direction. If the sun is too high, the angle isn't right, and no rainbow will form. Rainbows aren't just beautiful, they're also used in science and technology. The same principle of light dispersion helps us understand stars, planets, and even distant galaxies. Astronomers use something similar called a spectrometer to study the light from space and learn what elements those stars are made of. So, the next time you see a rainbow stretching across the sky, remember that you're witnessing sunlight being bent, reflected, and split millions of times inside tiny drops of water. It's nature's way of painting the sky, using physics and light. If you enjoy learning about the wonders of science, make sure to subscribe to my channel How Things Work and comment the next topic you want to learn.